I see a few of you were here. Awesome, awesome. Okay, so I'll just briefly talk to you guys, just 2 minutes about what we have gone through in the last session and what we will continue today. So let's go ahead and I'll share my screen and we can start on that. Okay, so firstly, I want to let you know about my GitHub and the materials that we will go through for today. So let me see. Oh, yes. So we went through this file last week, I think. Yes, it was last week. So we went through about the distribution system, what it is, why we distribute a system, and what is distributed data store. And we touch a little bit on Spark and what it is, how Spark SQL work. And for the content today, we will talk about how to build a machine learning pipeline on Spark with Google Colab. And one topic that I want to mention to you guys to maybe later to read up later on and do some more research on that I didn't touch up on last time is the distributed system synchronization. It is a very, very important topic because as you can remember, in this gap theorem, right, we have consistency, availability, and partition tolerance. So for the consistency and availability, how do you make sure that when there's some change in your data, it will be available constantly, it will be consistent with the how does the system will be updated and keep things constantly. So that is where we need to understand about the distributed system synchronization. So there's a very, very famous paper that was written in 1978 by Leslie Lamport.
Hey Jane, sorry, can you wait a minute? So basically what's happened, there was a mistake in the schedule. So sorry, it's our fault. So basically there are gonna be people joining. So basically the schedule was saying 8:30, which is instead of 8. So if you give a second, we're announcing to the people. So this way we give you,
Sure.
well, I'm sorry about that. That's why I was away. I'm trying to figure out how to fix it. This way we give you your proper, presentation. Anyway, you're the lucky last one, so we cannot. We're gonna give you free. We're gonna give you a free pass. Do our mistake when we created the schedule.
Right.
So basically, people think you starting a half an hour after, because the other times were right except the IST, which was 8:30. So now people are off. So now we communicating with them manually to tell them, hey, join. So,
Okay, no worries.
Yeah, sorry about that. It's my fault.
That's all right. So actually, I have a video. We can go through that video, and then once people join, I can do a recap on the distributed system synchronization, and we can start with the Spark Spark machine learning pipeline. Oh, meanwhile, please, I'll show you guys how to access this file on Spark machine learning pipeline while we wait for other people to join. Just a moment. Oh, I lost my own GitHub link. Okay, let me open my GitHub link again. Sorry, my computer is a little bit messy. So here, if you go into training documents, I think most of you guys have my GitHub link already. So if you go to the training documents, you go to Cloudera Cert and you go to Spark Training. So in the fourth one, so in the fourth one, you can see that's the Spark ML and you can start copy it and we'll go through it once after I talk about the distribution, the synchronization. So we will have chance for other folks to join in and have questions and participate in the set up Spark machine learning pipeline. So I just want to head up also. So this is just setting up the pipeline. It doesn't go through with the, modeling and things like that. So I want to help you to get a startup on this. And then after that, you can explore more on the model later on. And if we are lucky, then maybe I'll have another session if the class permit to touch up on like how you can get some machine learning on Spark and things like that. Okay, so let's go back to the slide. I think we have quite a number of people already. So let's go back on this. So I was talking about the paper that was written in 1978. This was really, really long ago by Mr. Leslie Lamport. So he was talking about instead of relying on the physical clock. Oh, sorry, I make a mistake on spelling. So physical clock is what each of the system has, so in your computer, you have your own physical clock, and in your friend computer, you also have a physical clock, and these clock are not, is different from one another. So there's no guarantee in synchronization. So when he was written this, he was introduced a new concept, which is logical clock. So basically, what logical clock is, if A happened before B and B happened before C, so A must happen before C. So if we think of that, then if A happened before B, then we want the clock to have clock of A to have lesser value than the clock of B. So basically, what logical clock is a function that take event and return timestamp. And to be able to understand further on how does it work and the algorithm behind it, then please visit the paper. And I also include a link here from University of Utah that talk more elaborate on the different synchronization for the distributed system. And also, when you read these papers online, like in the class about distributed system, you can sometimes heard about Lamport clock, which is also another name for logical clock, because this guy name is Lamport, so they use his name to naming the clock also. So that is just one topic that I didn't mention about last time. So I want you guys to know, and maybe you can read more on that later on, because when you go into distributed system theory and understanding these concepts is very important. All right, so that is what I have transferred to you guys so far about the distributed system, and I think it would be a good base for you guys to start learning deeper. So let's don't waste our time further, and let's start a notebook. So do you guys access to the notebook? All right, so basically please don't run on this notebook directly, but rather please make a save on that, so you can save a copy to your drive. Please let me know if you guys access the notebook. All right. Oh, Leo, I think can I start this, or would you prefer we wait a little bit?
Yeah, everybody joined. Sorry.
Oh, okay. Awesome, awesome.
So, yeah.
Okay, yes, that's awesome. So please let me know if you guys have issue with accessing it. I'll give you guys a few minutes, then I'll explain through what we tried to set up last time, and then we can proceed with the building the machine learning pipeline head on. All right, so let me have a few minutes to talk about what we did last time. It's related to Spark SQL and data processing and cleaning. Sorry, data cleaning. So before you do building any machine learning pipeline, before you start running and splitting your model, your data set, it's recommended to do some cleaning. And in Spark is you have Spark SQL, which will really help you with cleaning the file. So how you set up Spark on the Collab. So basically this part you can ignore it, just let me know the environment that Collab give me. And also there one good thing about Collab is that you can choose CPU or GPU to run it on. See in here, I choose GPU, and there's the spec of the GPU that I have. So it's just something for fun that I like to see what I was given. So you guys can skip it if you want. So before we install anything, then we need to get the update of the latest software of our environment. So that's what I was doing. And then this is the setup. So if you guys have joined my other sessions back in March or April, you will see like this code is so much shorter than the previous code that I gave. So this is the new update on PySpark. So please disregard the other notebook and use this instead. I also updated my other notebooks also. So please pull the latest version. And then this is where you mount your drive and get the data. And Spark measurement is so that you can debug and you can understand the resources of your code use. Yeah, this is just nonsense. Yeah, it's all right. So from here and below, there will be some context on Spark SQL and how you run it. So if you haven't been here last class, please go through it, and there will be information and guideline for you. So let's move to the notebook that we will have on this class. So this is the setup of Spark. I just go through, so I won't talk about it. So basically, this is the training kit. You will have to clone it now. And then let's start with Spark ML. So in this lesson, we will talk a little bit about the machine learning libraries that specialize in Spark. So of course, you can use scikit-learn, you can use other libraries, but then it's not optimized. So sometimes it not work. And there's a very unfortunate thing about Spark is that not all of the algorithm will work in Spark. So for example, I was trying to make live GPM works on the Spark for my company model. And the only library that closely available to that topic is mmlspark, which is from Microsoft. And even with mmlspark, there are a lot of parameters that I cannot customize. So for those situations, you guys would have to use, what I would recommend you guys to do is you have the training set and the testing set, right? So the training set, you might have to build your model in the Python, and then you do the prediction in PySpark. And you have to build a UDF function to get the model to PySpark, and after that you have to broadcast join to your model to each of the node. So that is a very advanced topic, so we have to reserve it later on, but I want you guys to aware that it is the possibility. And if you guys in that situation where you have to use like live GPM and with the parameters that you guys cannot use on the Spark, then that is the option that you guys can think of. But for normal use, so logistic regression, linear regression, they're all available in Spark MLib, which is native support by Spark, and you guys can use that. Another area I want to touch up is that mmlspark is work well. It works well on Azure, it works on Databricks, but then if you want to install it locally on your local machine, it might have some issues. If you install it like pip install mmlspark, I tried and it doesn't work. So what we did at my company is we installed through this one, and it seems to be working all right. I need to have some further testing, but I want to raise that issue up. So if you guys also have the same issue, then you guys can try my link to see if it helps with your situation. I need further testing, so I cannot guarantee that the link that I provide now is exactly similar with the mmlspark that you would use on Databricks. There's some issue with the versioning, so I'm still need to look further in the working out the issue. So those are the experience that I was having when I use the MLlib in Spark. All right, so those are the two main libraries that we could use when we use Spark. There's of course like MLflow, where you help you like keep track of the model versioning, and with that you need to open the port to let the display to let the website display. So if you guys have issue with the security, like I mentioned in the last session, then that is something that you also need to be aware of. Okay, so the second topic is how to build Spark ML to avoid what is the best practice to avoid leakage, and also how you pass all of how you pass all the multiple columns to do featuring and labeling. So these we will practice and we will analyze more in the below slides. I mean below coding slide. So so first, I hope you guys have run so far and run all right. So up into this, we just read the file and remember. So remember if you guys, oh wait, I haven't connect. Okay, so let me also run this. Oh, it will take, okay, here is show up. So after you mount your data, there will be like data set like this, and it depends on your drive. So you need to copy the path and you need to put it in here. So find the repo that contain my training documents, and in the training documents there should be the simple data. That is where you need to look at. This is not the correct simple data, unfortunately, so please don't look at this. But there should be the simple data in the training document. Oh, shoot, I didn't fill the check-in form also. Oh, okay. I'll have to do this later. Thank you for reminding me, Saya.
Yeah, sorry about that. We'll keep it open. Yeah, you're professional.
Yeah, because I was studying the whole weekend, so I didn't realize that we have. Okay, I'll have to do it later.
No, as long we haven't closed it, you can fill it. And since just don't worry about it. We'll leave it for you. So
Ah,
we'll
okay. Thank you.
take care of you. Go
Yes,
ahead.
yes, thank you so much, Saga. Yeah, I totally forgot about that. All right, where I am at. Uh, shoes.
Sorry if I threw you off.
Yeah, that's all right. That's all right. I'm just trying to. Oh, that I'm in the wrong notebook. No wonder. Okay, guys. So sorry. So back in the Spark ML, please remember to get the file location accordingly to your notebook. So for my notebook, this is in the training document, Cloudera, blah, blah, blah. So you see Spark training and simple data. I hope everyone see this one all right. And then you read the data in CSV. Normally, in the Spark, it's not recommended to read in CSV. You would do a lot with Avro and Bucket. So those are the format that in the real environment that this is the file that would be recommend for you to write and read from. But then it's just testing environment. So to make it easy for everyone, I read Spark CSV. So, these are just processing. We have been going through it last session, so there's nothing new on that. So the new part is this one. I want you guys to click on here and start looking at this. So this is from, I think, data camp. They have this. They have some few lessons on PySpark, and you guys, you guys can change this to be like, and then you guys can see all the lessons also. So I tried it lesson 1, 2, 3, 4, 5, something like that. So if you guys are curious about their content, you guys can change this to see all the content of them. All right, so this is the Leaky Model, right? So you have feed and transform the test file, you have fit the train and the test, and you transform the train and the test in each fit and transform. So it's not a recommend model. So what they recommend here to avoid the leakage. Let me just zoom it in a little bit so that you guys can see clear. All right, I think you guys can see. So here they recommend us to do first, yes, yes, they have a good learning material and good learning course on PySpark. Oh, actually, uh, I forgot the guy that participated in our class last time. He introduced a very, very good resource also. I'll post it on the channel. Data Structs. Let me see. It have really good content of PySpark also, so you guys might want to check out. Okay, yeah, Data Structs, I think. So I was looking at it also. Let me see by data struct. Okay, I promise I'll I'll send it to you guys. Sorry for.
Listen, just focus on your thing. What you could do as a suggestion, you focus on presentation. I really like the way that you're trying to help us. What we do normally, like these resources and thing, we have like appropriate like presentation channel or whatever. So I know you were working hard this weekend and you basically pulled this really late. So what
Okay.
you could do once you finish and you relax, you could post them in the channels, whatever links you
Yes.
want to provide. And also we have a folder too that dedicated to you. You could put whatever you want. So don't
Awesome.
worry. Just focus on that. We will help you with the rest. Don't worry
Awesome.
about it.
Awesome. Yes. Please help me keep track of the comments because I get a little bit sidetracked when I look at the comment and
We'll read them
send at
for
the
you.
same time.
Let's do
All
that.
right. So back into the pipeline, this is the recommended way to build a pipeline. So all the stage in here, you put in the pipeline at one, and then for the training and testing data, so the training, you feed the data, and the testing is for the transforming. So back in this one, how you do it with PySpark. So first, you install all of the dependent libraries. In here, I don't have PyArrow and Coalesce. So what Coalesce and PyArrow is? So in normal Python, you guys have pandas, right? So in the Databricks, you have to use, well, you don't have to use Coalesce, but then it's recommended for you guys to use Coalesce instead of pandas. And actually, Coalesce is built on top of pandas API, Spark API that resemble pandas to help data scientists to have the easier time with manipulate distributed data on the distributed system. But in order to use Coalesce, you need a certain version of PyArrow. And for my computer, like I use PyCharm and it works all right. But then for Colab, it's a little bit buggy. So that's why I couldn't demonstrate the ability of Coalesce and PyArrow in this time. But I want you guys to be aware that if you're thinking of using pandas in the Spark, it's better to use Coalesce because Coalesce is optimized for the distributed system. And with pandas, like I mentioned last time, if you the way pandas work is that it will pull every single file in different node to one machine. And if your machine is not powerful enough, it will break that machine. So your session will be terminated. So it's not a recommend practice at all. So instead, you should use Coalesce and Pyro. All right, so we need to install the dependence libraries. And after that, you can split into your data set, so your train and your test set and the seed, so that later on, if you want to split it in another session, that it will stay the same split. And you want to define your label and your features. And this is where you can have the code. So if you see that my code is a little bit different from this one, is because in my work it's actually happened. So So in here, if you can see in the code, in here you pass only one column, but then in the real life, you not only like take one feature column, you have multiple feature columns. So what do you do? So in PySpark version 3, you can input multiple columns in. So basically, in here, you just make it to be plural, then it solves the issue. But then for collab version and also for my work environment version, because we are still staying in 2 point something, 2.4, 2.7, something like that. So we cannot do that. And you will see it with a lot of distributed system on-prem is that we don't update it to the latest version because number one, it would be conflict with other libraries. And number two, we want to have the version that have more stability. So that's why a lot of times you need to find the solutions for the older version. So in here, it just so in here, like this is the method that I use, and I just demonstrate the code for you. So I think our time is up. So basically, you guys can test it out and
We have more time because we did the mistake. We were, you know, it was our mistake when we had a mistake in the schedule. So it's
yeah,
our job to make sure
that's
you
all
get it
right.
right.
That's all right. It's
You're the last one, so you're special. Go ahead.
Thank you. So yes, that's all right. Everyone can run the code at home, and if you guys have questions, you guys can ask me. I think everyone here is very advanced in Python, so I don't think there will be issues with my code. So basically, these are the stage that I want my pipeline to process. So indexer, encoder, assembler, scaler, and the reason why I have to I use vector assembling to my code here in PySpark. I want to raise this as well. So for Spark ML, you need to pack all of your features, column, and chain it in one column. So it's a little bit different than Pandas. So Pandas, you don't need to do that. But for Spark ML, you need to do that. So that's why it's very important in Spark that you have to vector assembler your code. So this is the stage that I would recommend you guys to do. Sometimes you don't need this. In Coder, it will split into a lot of columns. So sometimes you need it, sometimes you don't need it. Depends on your need, but this is the must. So indexer and assembler is the must that you need to do. And this is the result of the data frame. I didn't, normally I would drop the column that be renamed it, but then in here I want to keep it so you guys can see the change of the data after we process. And if you guys don't like, you guys can throw it away. You guys can drop it later on. But this is the result after we feature it and we scale feature. This is the result, which is like in all the metrics. All right, so since we don't have any more time, so we have some homework here. So since we finished with building the pipeline, then it's time for you to implement it. So think about how you do cross-validation, feature coefficient, feature importance, all of the statistic values that you have been doing in class and you have been doing with Python. How do you apply it to PySpark? Then because I think the channel is still gonna run later on after the class finish. So I'll try to set up another session that we can touch upon that. So that's it for my today's session. And now it's a Q&A, and let me know if you have more questions or if you would like to know more about Spark, then you feel free to message me later on.
Can I ask a question?
Yeah, yeah.
Before you... Okay, so it's a kind of not to this. Well, I really wanted to learn Spark for
Mhm,
other. So if you have the data coming live, like I had a situation where I have logs has to come from
mhm,
different servers, and we need to do some anomaly detection. So
mhm,
how would I have to do any tweak in this to make it more adjustable to live data that's get shipped from let's say you have 150 different servers that they send the log files to
mhm,
through a pipeline through
mhm.
Spark, because it's one of the biggest use actually I've been seeing it in the market is analyzing logs centralized. Is there anything you would advise from your own experience to make it efficient?
Uh,
Compared
Firstly, so which system do you use to receive the live messages? So do you use Kafka, Spark streaming? What did you use?
no, well, I've been consulting. So I had some Kafka and I had the Spark streaming. I had both.
Oh,
So I'm
okay.
really asking about the Spark streaming one. I don't know which one is better. I'm trying to get my hands dirty with the Spark. So
Mm-hmm. I
asking your
see.
suggestion.
I see. I didn't work much with Spark with real time processing. I'm more working with the Spark like batch processing. So for my company though, I know that they have the Kafka. So they have the model, they have the training model already. So when they receive the new messages, they will use that model to predicting the output. So the model is trained already on the normal data, and when you apply that model to the streaming data, so it will respond based on the model.
Okay, that's great. Thank you for insight.
You're welcome. So that is the model that my company use. I haven't used the Spark streaming yet, but I would imagine this is similar. Okay, so Sabi have the why make the pipeline. So this is not the Spark pipeline. This is the machine learning pipeline. So when you do data science and or machine learning, you want to make a pipeline to ensure that you don't miss any stage and your code is organized. And to take this further, so you can also like make it to be a function, to just help to organize your code and make sure there's no data leakage, make sure you don't forget things, make sure things not falling out of the organized. So it just helps to like really modularize and organize your code.
There's another question say where I could study the GP after the course is done. Um, uh, say where she could study the GP after the course is done.
Oh, hang on, let me take a look. Oh, my study group after the course ends, so I will still continue to host study groups on the Azure certifications, because that's what I'm going to take at least from now into March, and that's what I'm really passionate about. So I'll still try to find time to to host at least one study group or like one session per week. I'll have to check it out, because I'm currently studying for my master degree, and there's a lot of schedule in the weekend. So I'm still trying to figure out time. But I should be able to announce to the channel on the October, like the first week of October. So is it compulsory to create a pipeline? Well, is it the best practice to do that? I guess you don't have to if you just use it in like developing environment, but then in the production environment, it's highly recommended to do that. I mean, your model will still work, but then it's not recommended. All right, I think. Okay, I just want to make sure I click on here just in case I miss it. Yes,
And
thank you
if
for
you
dropping.
really have, if you have any questions about the forms where like give the thing, just the
Oh yes, yes,
message anyone of our team who will help you.
yes. Thank you so much. I'll have to fill out the form. I forgot as well. So, guys, you have any other questions for me on distributed system or Spark ML? Thank you so much, Sabine. All right, I think that's it. If you guys want to keep in touch with me and let me know more about Spark, so from now until March, I'll still be maintaining and hosting sessions on the channel. So the channel that I will be most likely to participate, to present, to be available is the Azure certifications, and also the study group data set prep. So hope you guys. I think the I think it's a little bit long, so please remember the name,
It's
and
a
you guys
executive
can join. And yes.
Yeah, thank you for your time. I know, I work with you and you had to really work hard to pull us
Yeah.
last seconds.
Yeah, thank you so much, Leo. So yes, so yes, so please join my channel. You guys can also keep in touch with me by my LinkedIn if joining the channel and going to Slack is not so convenient. So LinkedIn would be the second mode, or my GitHub, where I put all of the training materials. So I guess I think my session concludes now. Thank you so much, everyone, for participating, and hope the session was useful for you guys. And see you guys later. Bye bye.
Thank you.
Thank you. Bye bye.